This is a set of recordings to help you develop your circuit. Since my class does not have a background in developing circuits, I thought this video might be helpful. In the past, your instructors gave you circuits to build in the lab and to do analysis. These circuits were designed by the instructor using basic circuit theory, or they were borrowed from various books and websites to help the student understand the function. Now you're in a position where you want to create a new system, and you might assume that your instructor knows all the details and can construct all the circuits instantly. I'm sorry to say this is not the case. You're in a position now where you have to develop your own circuits, and this is called the solution for your project. Right now, you have something called a block diagram, where you have defined your input components. You have selected the controller that you're going to use. Some of you are using a microcontroller, such as the basic stamp, and others are using a PLC. And then you have a list of output components that you're going to control. And the condition of these output components depends on the status of the inputs. And you will provide the first level of solution to your project by creating a block diagram. Now you must move further and create the actual circuit diagram that you need to finish your project. I will demonstrate this idea by using a block diagram myself and help guide you through the creation of the circuit. Let's assume that I have as my project two inputs, a temperature sensor and a motion sensor. And I decided that I was going to use a microcontroller as the controller, and that I was going to control a fan and perhaps a lamp. And the temperature sensor sends a signal to the microcontroller as well as the motion sensor, and the fan will receive a signal from the microcontroller, and the lamp will receive a signal from the microcontroller. I've also learned through experience, and I've given this to many of the students, that your temperature sensor is an analog device, and you cannot connect an analog device directly to the microcontroller. So I suggested that many of you use an analog to digital converter to solve this problem. The motion sensor that was selected for the group is a digital, produces a digital output, so it can be connected directly to the microcontroller if it's operated at the proper voltage. The fan is just an object or a component that needs to be turned off. The speed of the fan does not need to be controlled. Therefore, it's just an on and off device, so it is digital. However, since the fan needs more current than the microcontroller can produce, I suggested a driver to be interfaced between the microcontroller and the fan. The same idea works for the lamp. The lamp needs more current than the microcontroller can provide. Therefore, a driver needs to be placed in between the microcontroller and the lamp. So in actuality, my block diagram looks more like this. And I believe most of you have decided that this is at where you are. Now the next step is to actually build a circuit. We say design a circuit because there are many solutions to this problem. There's more than one type of circuit that can be used to solve this problem. Here's the temperature sensor, motion sensor. Here is the analog to digital converter. Here's the microcontroller or PLC. Here is some type of driver. And lastly, you have your fan and you have your lamp. So this is the complete block diagram that I expect all students to have at this point. Now, to give you an idea of where we're going or what we expect you to produce, I would like to look at one or two sample circuits. This will give you an idea as to what your solution might look like and what is the structure of that solution. Let's look at this system. The first thing you might notice is that there is a line across the top and there's a line across the bottom. In most circuits, you will see that they are structured in this way. Very similar to how a ladder program is organized, where you have a rail at the top. We call it a power rail. And usually the plus is at the top and the minus is at the bottom. And notice that this solution requires not one, but two power supplies. So this rail represents a 6-volt power supply, and this rail represents a 2-volt power supply. So in actuality, you have two power supplies that is needed for this project. You need a power supply that delivers 6 volts, and you need another power supply that delivers 12 volts. Normally what happens is that you have a 12-volt power supply, and then you use something which we will talk about later called a voltage regulator that will allow you to put in 12 volts and output 5 volts, like a voltage converter. And you can also use something else that we talked about before called a voltage divider, where you put in 12 volts and you select the correct resistors to output the 5 volts. In this example, I'm sorry, it's 6 volts, but you get my idea. If you look even more closely, all of the blocks, there's a line that extends from the top of the block that goes to the power rail. This is typical of most designs of circuits. The vertical lines is what is used to connect to the rails. All the vertical lines generally are connected to the rails. Okay? And the horizontal lines, that represents what we call your signals. So your horizontal lines will look very similar to what these are. So as you can see, your block diagram did not show you the power. It only showed you the signal information. It only showed you the signal information. It did not show you the power. So when you make your rails, you have to add, when you make your final design, you have to add signals to your results. And of course, there are extra components that might be needed to help operate your system, such as you might have to add some extra components such as some resistors and maybe some diodes to help control the current distributed throughout the system. So normally in this system you would probably only have 1, 2, 3, 4, and 5 blocks. This would have been your sensor. This would have been some type of signal conditioning. This is your microcontroller. This is your driver. And this is your final load. But as you can see, when you start creating the final circuit, there are some differences. So I would like to summarize that signals are usually drawn as horizontal lines to correspond with or to match up with the block diagram. For power, there's usually rails, one at the top for the positive and one at the bottom for the negative. Usually you can also use this symbol to represent a connection to the bottom rail, and you can use this symbol as a symbol to connect to the top rail. This saves on the number of lines on the screen. And there are probably extra components usually that are needed by your circuit to help control the current, or in this case here is used for protection. So your goal now is to translate or to convert something that looks like this into something that looks like this. In the next video, we'll get started with our sample.